performance. We talk about availability, we talk about T-SQL, we talk about ledger, but the idea today is focusing on the features that are related to performance. All right. Actually, there are many to cover, so the idea is to go through them and see them in action. One of the important things to mention is that these new features are not only for SQL Server 2022, they also are available in Azure SQL, and we will see them through the presentation. So a little bit about myself. Well, this is what Ross mentioned in his introduction. Besides that, I'm also a former member of the Azure Data Community Advisory Council, and I'm also running a user group down here, is SQL Argentina. We have our meetings in person, virtual as well, and they're in Spanish. So if you would like to have a good time and connect remotely and you feel okay with the Spanish, definitely you are more than welcome to join us. In the screen also, you will see my contact information related to my social networking, my Twitter, LinkedIn, my blog, and also my email address. Feel free to reach me if you have any question regarding to this presentation. All right, this is some of the topic that we saw last time. We covered what Azure SQL is and the components, right? Is SQL Server as we know it, what I call on-premise or SQL Server product. You will hear me saying SQL Server product more than once. It's basically the SQL Server that we've been using forever in our bare metals servers, our laptops, or our virtual machines, right? Now we have this new umbrella called Azure SQL, in where beside the SQL Server product, we also have Azure SQL virtual machines, right, which are actually the running the same SQL Server version and edition that we've been using, but on Azure virtual machines, which is good. That is what we call infrastructure as a service. But then there are two other components of the Azure SQL family, right? Managed instance and Azure SQL database. The main key of these two components is that they are platform as a service. So we don't have to deal with the infrastructure behind the scenes, server, cluster, patching, backups, antivirus, high availability, disaster recovery. No, all that is coming as part as the service. So we just need to connect to each of these components or any of these components, deploy our user database, and focus on the application, nothing else, right? It's like the idea of having it in some sort of autopilot, right? So SQL Server 2022 is not just one new version, it's the evolution of what Microsoft calls the modern version of SQL Server, right? Starting by SQL Server 2016, a quick parenthesis here, you know that soon in July, SQL Server 2014 will be discontinued in terms of supports, right? So it's also important to plan ahead. So the modern versions of SQL Server are from 2016 onwards, 17, 19, and now 2022, right? Each of these versions have new features, but at the same time, evolutions of features coming from the previous version. And believe me, in terms of performance, they have done a good job. And there are some features that were introduced back in SQL Server 2016 that have evolved a lot. One of them, which we will see in action later on, is Query Store. Right? Query Store, we will cover it, as I said, but just to give you a sneak peek, in these three versions, 2016, 17, and 19, Query Store was available, but not enabled by default. Right? Now in SQL Server 2022, when you create a brand new SQL database, right, a user database, will have Query Store enabled by default. And this is also to mimic the behavior that we have in managed instance or Azure SQL database. Right? So when there is a new database created, Query Store is enabled by default. Right? So a lot of features related to performance, availability, security, and as we mentioned last time in SQL Server 2017, we had the great let's say surprise that now we are also able to run SQL Server on the major Linux distribution, right? So it's the same SQL Server that we have on Windows, but also we have it in Linux, right? So we saw this slide last time with all the features that were introduced specifically for 2022, right? Today we will focus on the performance and availability, actually the last part of the slide. Well, what is interesting to mention, and actually is a question that I normally get, is there anything different? Is there something that we don't have to do anymore, or something that has changed since when we started? And I will say 95% of the cases, no. Right? If you are a DBA and you have to, dimension an environment to run your production workload, and then being able to maintain the performance, most of the things that you learned back in the days with SQL Server 2000, for example, in my case was SQL Server 6.0, remains quite similar, I would say. There are, of course, new additions, but when we have to talk about performance, we have three main pillars, right? CPU, memory, and storage, I/O, right? So these are the three main important things on any SQL Server environment. If one of them is in trouble, if one of them is under pressure, we will definitely notice it right away, and the whole environment will start being degraded in terms of performance. So these are the three things that doesn't matter if it is a virtual machine, if it is a SQL Server product, and actually if it is one of the PaaS services, we always have to take care of these three components, right? Then, of course, a good index strategy is super important. Right? SQL is giving us a lot of feedback, from the missing index dynamic management views, but something also that I get from the, let's say, some of the new DBA that are starting is, do we have to just go there and create those indexes right away? And the answer is definitely no. You have to evaluate carefully, because just creating indexes just over there could give you some temporary benefit, but in long term you can also have troubles. And that if you have tables with multiple indexes, that's going to be a problem. All right. We will see some new features related to this, to the index management that are targeted to Azure SQL database. Right? And then the part that I would like to focus is intelligent performance. Right? Something that we touched base last time is that we can have the super duper SQL Server running our state-of-the-art application, etc. And we say, we have enough CPU, we have a lot of memory, we have the faster disk. But one problem that we will always have is that we won't be able to have a predictable performance. What does it mean? I have a report, a store procedure that runs in few seconds normally, right? Let's say a report. And one day, out of nowhere, that same report start taking hours, right? And you ask me why. I have the best server, I have a lot of memory. Why is that? Well, we have this thing called plan regression, right? That definitely we will touch base in during this presentation, which is because it's super important. So the goal is not have, I mean, it is have a good and great performance in terms of duration, in terms of resource usage, right? But at the same time, especially to me, right, is being able to always have the same predictable performance, no matter if the server is completely idle or if it is stressed out until the top, right? If we have CPU usage over 80% for a long time, I don't care. I will always want to have the same predictable performance. If my report takes 2 minutes, I want that to take 2 minutes all the times, no matter what, right? And in order to do that, every DBA has to do the maintenance task, right? Something that will never change. So definitely we have to take care of the statistics, right? This is super important because, you know, if SQL Server, if the query engine, the query processing start getting out of date statistic, the execution plan that the engine will come up with won't be accurate. And that is where we're going to start having troubles in terms of non-predictable performance. So definitely things that Microsoft is fully aware of, and the features that they've been working on, again, since SQL Server 2016, are basically to accomplish that objective, right? Besides great performance and better performance with version after version, being able to have predictable, continuous performance, period. That is the goal, right? All right. And in order to do that, they came up with this concept of intelligent performance, right? The idea is to give us tools and components that basically will be doing some of those repetitive tasks that we normally have to do when we are monitoring performance, right? And being able to adjust some of the parameters on the fly in order to, again, accomplish that objective. So this intelligent performance is the key component of every SQL component, right? SQL product, managed instance, or Azure SQL database. Right? Okay, a little bit of history on how Microsoft has started this initiative of intelligent performance. Back in the days, SQL Server 2016, they came with this concept of query store, right? Which we're gonna describe in details in a minute. Basically, query store is just a performance database for all the workload running in my user database, right? So that was the very first introduction of this intelligent query processing. Next, they added this automatic tuning, which basically works at the top of query store, doing some of the things that were still manual, right? In 2016, trying to make them with some automatic procedures. Also, in SQL Server 2017, they came with this concept called adaptive query processing, which then in 2019 was renamed, right, to intelligent query processing. The idea of adaptive query processing / intelligent query processing is basically the idea of when the queries query processing, the query engine, come up with an execution plan, right? You know that we come up with a query or with store procedure. First time we run it, the query processing will compile the execution plan. We come up with the execution plan. What is an execution plan? It's basically try to come up with the way to resolve that query based on the statistic that we have on the system, right? And then when we have the plan, right, we're gonna use it. And then, the next execution, we will have that plan in cache, right? And we will continue reusing it until, for some reason in the future, that plan may change for some reason, right? But first time we execute it, it's gonna compile the execution plan and we'll reuse it. So intelligent query processing, what it does is basically every time that the plan is taken from the cache or the query store, we'll see it later, basically what it can do, what the query processing can do now is provide some feedback from the execution, right? So, hey, maybe you need to tweak this. So the following execution will be tweaked that way, right? Oh, maybe you have additional memory grants that you don't need. Oh, the next execution is going to be adjusted, right? Before that, we just get the execution plan, and the execution plan is not always perfect. What SQL Server, the query processor, does is try to come up with the plan as quickly as possible and as good as possible, right? But that as good as possible is not always the best option, right? So before, if the plan was not good, we had those problems, those regression problems, right? Something that normally takes an X amount of time. And one day when we come out with the other plan, which is not good, it starts taking forever, right? So with this feedback that each execution is giving it back to the query processing, right, is trying to adjust the plan on the fly, something that before was completely unthinkable, right? So being able to adjust the plan on the fly was really good, and actually nowadays is one of the most important features related to performance, and again, to accomplish that objective that we said at the beginning, being able to have predictable execution, right? In SQL Server 2022, right, in this area of intelligent query processing, Microsoft also called it next generation of intelligent query processing because it added 3 more features at the top of it, which are cardinality estimation feedback, DOP feedback, and parameter sensitive plan optimization feedback. These 3 were the ones that we briefly covered last month. So this whole concept of intelligent query processing is basically having a process monitoring the execution on every single query, all the workload in my user database, storing it, analyzing it, and adjusting it on the fly to, again, do the predictable performance. What we were doing before all this, we have a DBA just watching the monitoring console and say, hey, here we got a regression. Let's troubleshoot. And troubleshoot means maybe drop the execution plan and recreate it, clean the cache, even recompile the store procedure, or many other things, right? All those things that we used to do manually is what Microsoft has learned over the time, and is trying to put processes that are taking care of that more efficiently, because as soon as this get detected, it's going to run it and apply it right away. So query store, as I mentioned, it was created or introduced back in SQL Server 2016, right? You have to enable it per user database. As I said, initially it was not enabled. You have to manually enable. Now in 2022, you have it by default. What is that? Is what I mean. The best comparison that I like is with the black box of a flight, right? When you every single flight, it has the black box on the plane, right? So that black box is capturing all the statistics, all the inputs, all the sensors, and storing it for any kind of usage. Query store is exactly the same. It's storing all the query plans that change over time, as well as the runtime statistic for each of them. What does it mean? You run a query, it will store in query store the direction, the number of reads, the number of writes, the usage on the TempDB, etc. If you run it again, it will also collect the same parameters, and you will have a paneling where you can see how many times that was executed and was the minimum, the maximum, the average, duration, reads, writes, etc. Right? So it's like a performance repository of all your live workload that you have over there. And then you have a lot of, let's say, reports, nice reports that you can use to identify which are the, for example, the top 25 process that I take in most of the resources, read, writes, execution time, etc. Right? So how does it work? Well, before Query Store, we used to have what I said. We run an ad hoc query, a store procedure for the very first time. It's going to compile and then execute it. Now we have this middleman in between, which is completely asynchronous, right? That when the plan gets compiled, it's sent it to the query store, so it gets inserted into this repository, right? And then after executing the query itself, the runtime statistic, which of course has to be created after it gets executed, right, is going to save that information as well. So you have this big repository of performance data of your user database over there available for you, right? So then from Management Studio, you have all these reports that, again, you can see all the queries that have regressions. Regressions mean that, they were executed in a certain amount of time and then suddenly start taking way more. And then top resource consuming queries and few more, right? You can, and the part that is really interesting here is that if you find a query or a procedure that has a regression because the new plan is not as good as the previous one, you can go to the query store panel and manually force a query to use the previous execution plan, which was better, right? So you can do it from the graphical user interface, or you can do it with SQL with these examples that I put in there, right? So, wow, we have all this information here, and if we see a regression, right, we just go there, we force the last plan, we don't need to recompile or anything, we don't need to do any code change, right? We just go there and force the previous plan. And with that, we go back to the performance that we had before, right? So that was awesome back in the days, right? But, there was something missing. What happened if in the middle of the night, right, we have this regression and we have no DBA in front of Management Studio and the Query Store report just to go manually force the last known good plan, right? That was a problem, right? Because, we had the regression at 3 a.m. in the morning, and then until, a DBA get into the office at 8 a.m. or something to go detect it and force it, we have all these execution with bad performance. So in SQL Server 2017, at the top of Query Store, Microsoft introduced automatic query tuning. What automatic query tuning does is that it automatically detects when there is a query that has a regression because of a plan change and automatically force the last known good plan. So if we have a problem with one query at 3 a.m., right, and we have automatic query tuning enabled, right, what SQL Server will do is basically automatically force to the last known good plan, right? And with that, again, even if it is 3 a.m., 1 a.m., or whatever, it's going to automatically do it. And not for one query, for all the workload in my user database, right? So what is a plan regression, right? As I said, SQL, the first time that get the store procedure, it will compile and it will get and put the plan and will store it and use it. Then could be multiple reasons why the plan needs to be recompiled again, manually or statistic change or resource constraints, etc. But the plans may change once in a while. One of these plans could be, as I said, not optimal or suboptimal or way worse than the previous one. So in one of the execution, we're going to start taking forever. What automatic plan choice correction or automatic query tuning does is basically just put it back to the last known good plan for us. So we don't need to have a DBA sitting in the monitoring controller checking the query store regression query or anything all the time, because SQL Server automatic plan correction will do it for us. And again, this is another step on the way to accomplish the objective of predictable uniform performance. I will stop here for a second to see if there are questions. No, we're good.
Yeah, it looks like all seasoned professionals.
That's great. That's great. All right. So we talk about indexing, right? And again, this is one of the important things that every DBA has to do, right? One of the Azure SQL component is Azure SQL database, right? And even if we have query store and automatic query tuning available everywhere, right? We also have the possibility of doing automatic index management, right? Just for Azure SQL DB. What is automatic index management, right? Which by default is disabled, right? The query processing will compile and will execute a ton of queries, right, in your user database. And if it detects that an index will be beneficial to improve the execution of one of those queries, right? If we have this feature turned on, it will create the index automatically for us without us having to do anything, right? So if it is detect that one query will take the benefit of a new index, right, it will just create that index for us without even notifying us. And again, we can also add the possibility of eventually, if that index is not longer needed, right, because it's not been used for quite some time, it can also be dropped automatically, right? So we have like a little guy over there creating and dropping indexes for us without letting us know, right? I mean, I'm old school DBA. I definitely don't like anything to get into the user database to create and drop indexes. So, it's good to have it. I tried this feature. It works really, really well, right? But you have to be careful.
I've got a question for you.
Yeah, yeah.
So let's say you have drop index off and you have create index on.
Uh-huh.
Are the indexes that are created by Azure SQL database still subject to being deleted as long as it created the index itself?
If you have create index enable and drop index disable, it's gonna create indexes the same way that you manually may create them, right? Create index name. It will choose the columns, the necessary column for you, right? But if you have drop index disabled, it won't drop any index, right? But let's say that the following day you see one table that has too many indexes, and you just want to drop them, you can just go there and drop them manually. That is not a problem. I never tried the other way around. I mean, just drop indexes, enable and create index disable. But anyway, not sure. I believe that it works based on the index name as well. It's not going to touch indexes that you create manually, right? It's going to just touch those indexes that get created automatically. Right? That is why you also have the possibility of turning on and off. And the force plan option that we see here is automatic query tuning, actually, right? But you can do it from the Azure portal. Okay. Query store and intelligent query processing. As we said, this database and this process at the top of it that will automatically try to force the plan if there is a problem, right? In SQL Server 2022, right? At the top of this, and using Query Store, and also taking the benefit that now Query Store is enabled by default when we create a new database, right? We have all these new features available that we will touch base in a minute. I also mentioned intelligent query processing next gen, right? How to use it, right? We, of course, every time we want to enable all these features, we just need to change the compatibility level, right? So if we have SQL Server 2022 and we want to use all the features, we need to change the compatibility level to 160. And with that, we're going to be able to use all those features, right? But going a step backward, what intelligent query processing is, right? Remember, initially it started with the name of adaptive query processing in 2017, right? And it has all the features or the sub features, let's say, which are in light blue, right? Then in SQL Server 2019, it was rebranded as Intelligent Query Processing and added many other features. And in 2022, the one that we just described before, parameter sensitive plan optimization, cardinality estimation feedback, and DOP feedback. So what is all this? Well, as I mentioned at the beginning, before all this, when you have the plan compiled to be used, let's say that it grants a lot of memory for some reason, right? Doesn't matter the reason. Every time that we execute that query, right, it will use that plan and it will consume that memory, period. With intelligent query processing, after executing, it will evaluate, oh, do I have this memory? Am I using all? Do I need more? So the following execution will adjust it manually. I have an example for that. And this is basically the ones that are called memory grant feedback, which are one of my preferred ones, right? So memory grant feedback. We execute the procedure. We come up with the execution plan that say, hey, I will grant 10 megabytes of memory for this execution. Okay, very good. Then after running the query, instead of using 10 megabytes, it's using only one. So there are 9 megabytes of memory that are waste. You can tell me, oh, it's just 9 megabytes of memory. It's not a big deal. We have servers with ton of gigabyte of memory and even terabytes, right? So I shouldn't be worried about this. But what if I tell you that this specific store procedure, which has this plan, is being executed hundreds of times per second, right? For every execution, SQL Server will allocate this 10 megabytes of memory and will ended up using only one. So we're going to be wasting memory, and that we're going to have a resource constraint, making the whole SQL Server to not perform efficiently, right? And we won't be doing it correctly. And even worse, I would say, if we allocate 10 megabytes because of the plan compilation, and then we ended up using 20 megabytes, what's going to happen, right? The query will, of course, be executed no matter what, but those additional 10 megabytes of memory that we don't have granted is going to use the 10 dB. It's going to go to the disk to fulfill that memory that is pending, and the execution will complete, but will definitely take way longer than if it is the optimal amount of memory. So what memory grant feedback does is that after each execution, it will evaluate the amount of memory that is really needed and will adjust that parameter, and the next execution, it will use the right amount of memory, right? We will see it in action, and definitely is something super good. All these features that we're covering here, the goal for Microsoft is also something super important. And what I said at the beginning, being able to have predictable execution, right? Now I will add an additional statement to that. With no code change, right? Without you having to enter into the store procedure or the query and just start adding hints or tweaking things. No, all this is without any code change, right? This is super important. Then in adaptive query processing, we also have adaptive joins. That is one of the sub features, let's say, right? What adaptive join does? Well, it will use one type of join or the other, depending on the amount of row that each of the joined table will return at this specific time. Let's say we run the store procedure, the query for the very first time. The tables are returning, let's say, 10 rows each in the join. What SQL Server or the query processing will tell us, oh, maybe here I can do a scan because there are just 10 rows on each of the tables. So it's not going to be a big deal. But then, we're going to have more and more rows in our tables, and the same join can return 1,000 of rows, right? So it will be using a type of join that was initially created for when the table has just few rows. What adaptive join does, it evaluates the amount of rows coming before executing and will use one type of join or the other depending on the amount of rows, right? Again, end result is with no code change, we have adjustment of the query plans and predictable execution. Right? Then one that I like a lot, actually, is this one that we have at the top, scalar UDF inlining, right? When this feature was released at the top of intelligent query processing, the marketing or the slogan was Microsoft finally fixed a bug that was there for 30 years, right? And why is that? Well, all of you know scalar functions, right? So, they are good for certain things because you can, let's say, put on the same envelope a lot of business logic on a scalar function, and then you use it, right? But for DBAs, these are not our favorite or our best friend. And why is that? Because when you put all that logic within the scalar function, what SQL Server used to do before all this is saying, hey, I will consider that this function or everything that is within the function will count 1. So I won't spend any time and resources coming up with an execution plan for this, right? I will always consider it as 1. And then in SQL 2014, they changed a little bit the logic, but was terrible. And we have seen this scalar function in the where clause, right? So it was just converting everything to a big cursor. And I remember many times, and this is super difficult to troubleshoot, right? Many times, running these queries and having 100% of CPU usage because, this scalar function, I mean, the logic within these functions were terrible. And again, the problem was that Microsoft was considered then that super light. But again, developers get creative and put all the business logic on it. All right. Now, what SQL Server is doing with intelligent query processing is before compiling the whole plan, it will dive into the scalar function. It will compile the execution plan for the function, and it will be embedded into the main plan. And with that, it's way more accurate and again, more predictable. Then there are a few others. The one that I like a lot actually is approximate count distinct, right? This is also part of intelligent query processing. When you do a select count distinct on a table with millions of rows, that's take forever, and these operations basically are memory intensive, so it will consume a lot of memory. Right? When you finish running the select count distinct value, you're going to have that value. But what Microsoft has introduced here is the approximate count distinct. Right? So it's a light way to do an approximate count distinct, way more efficient, right? Faster and with less amount of memory, right? But you can tell me, hey, the number is approximate. It's not the value that is really the one that I need. But let's assume this select count distinct is just to fill a bar in a Power BI chart. So what Microsoft is saying that the difference could be between plus minus 3% of the value. Right? So if you really need to get the value because, for example, is a financial thing that you need the select count distinct, you have to use the one that you are already using, right? But for the cases in where maybe you want to do it faster and with less resource usage, and you are okay just having the approximate value, this is way more efficient. Parameter sensitive plan optimization, the one that we saw in SQL Server 2022, right? We mentioned this last time. You know, everybody is familiar with this concept of parameter sniffing, right? When we compile the store procedure for the very first time, it will use one input parameter, right? And it will store that plan. But then we can use, I mean, following execution can use, most probably will use different parameters, and the plan that is in the cache is basically the one created for one parameter, and it's not always so effective. Right? So before parameter plan optimization in SQL Server 2022, we execute the procedure with the parameter number one, and it's gonna do a seek, an index seek, right? But if then we execute it with another parameter, let's say 10, it will probably use and scan because of how the distribution of the values are in our table. So that's the one that will store in the cache. But then when we go back to execute my procedure with the initial parameter, it will use the plan that is stored in the cache, which is scan. So definitely it's going to take way longer than the initial time. Now with parameter sensitive plan optimization enabled, right? When we execute the procedure with the parameter number one, it will have the seek as a plan. Then when we execute it with the other one, it's going to come up with the scan for sure, right? But what SQL Server will do is to store both plans, right? So depending of which parameter is input, right, it will use one plan or the other. It will store up to two plans, right? So let's say if I have a possibility of entering an integer value, there is not going to create one plan per parameter, right? It will try to use, you know, the ones that are stored there more efficiently. We also mentioned last time DOP feedback, right? One of the feedback that after executing the query, it will, you know, maybe the query processing detect that the query will run more efficiently with a different DOP, right? So instead of changing it at the instance level or database level or adding the hint, SQL Server will do it for us, right? So it will detect after several execution if it is needed to lower down the DOP just for that query, not for everything, just for that query. And if it does, right, it will do it for us again without any code change, right? So we run the query for the first time, the query processing will compile it, right? And using the query store, right, as again, this repository of performance data, right, it will evaluate if eventually it will require another DOP. It will force it automatically for us without code change and will evaluate if the change is more efficient, meaning that the next time that we execute that query, it definitely using less resources and is faster. Right? And it's not only one time, right? It will keep doing it to try to go to the more optimum value. It's always lowering down the DOP, never going up, right? At least on this version. This is what Microsoft said. Again, I'll stop here if there are questions. Okay, we move on. All right, this is actually introduced in 2019, but it's one of my favorite features. Every time you run a query, right? You don't know how long it's going to take, let's say, right? Until it finishes. So you have to wait. And maybe it's just few seconds, but maybe there are, several minutes. And what if that is running a report that is super important for the business, and it's running with a bad plan, and we need to take the decision whether to kill it or leave it running because it's about to finish. Before this, we don't know, right? Now, with lightweight query profiling, which, by the way, is enabled by default in SQL Server 2019 and onwards, but also can be enabled with the trace flag 7412 in 2016, Service Pack 1 and 2017. What you have is this estimated execution progress, right? What is that? If you run your query, for example, from Management Studio, you will have this counter, estimated query progress, which is a percentage, right, from 0 to 100. It won't tell you it's going to finish in 2 minutes, in 1 minute, in 10 seconds. It will tell you the execution, the estimated execution progress up to that point. And with that, you can estimate how long it's going to take, right? So now, when you have this problem that you have to take the decision whether you leave it running or you kill it, you can go check the light query profiling option to see the estimated query progress for that execution. You can tell me, I don't run my processes from Management Studio. I run the processes from an application that connects to the database. How can I enable this? If you go to Management Studio and you go to Activity Monitor and detect your session, right? You do right-click over the session and you put live query profiling, and you will see the query plan for that execution live with the estimated query progress in front of you, right? Super, super good. We will see it in action in a minute. In SQL Server 2022, many other features, shrink database concurrency, right? So we know that shrinking a database, data files or log files is always a heavy task in terms of IOPS, right? So now that has been rewritten, a hybrid buffer pool with direct write, way faster, auto drop statistics, also handling it automatically without us having to take care of. Something super important for every single DBA is to take care of the TempDB. We know that there are many recipes on how many files you need, the size. Before SQL Server 2019, you have to enable 2 trace flags, depending of, if the server has NUMA or not, you have to do it one way or the other. So it was always hard, same as MaxDOP, let's say. In SQL Server 2019, Microsoft removed those trace flags and put them by default, right? And also, enabled this feature called TempDB metadata optimization. That by default was disabled, but you can enable, right? So everything that is related to metadata in terms of objects in the TempDB, right? Instead of creating them on the disk, it's using this technology called in-memory, right? So, instead of using the disk, it's using the memory. So with that, you avoid a bunch of situations in where, SQL Server was creating multiple temporary objects concurrently, right? Because you don't have those logs anymore. In SQL Server 2022, that went a step further, and also the GAM concurrency was also adjusted. So now it's not that important how many files you create on the TempDB, right? Again, one disclaimer here, and one question that I always have. Oh, so now I can go and leave only one file, one data file, one log file. No, that hasn't changed, right? But let's say that if you don't do it exactly or the right way, doesn't matter. And even if you have one file, the performance won't be terrible, right? So this is what Microsoft called ham-free 10dB, right? Many other things introduced, right? Reduce buffer pool I/O promotion, spin logs and virtual log files, and instant file initialization on the log files, right? By default. Okay, let's see some of these features in action. Here I have my virtual machine, right? And we will, and here I have SQL Server 2022 installed. What we will see now in action is query store, right? So I have this user database that I just created. I create the data, here I drop it, right? And now I'm creating it again. And see here what I'm doing. I'm disabling query store. Remember, in SQL Server 2022, it comes enabled by default. So what I'm doing for the sake of the demo, it's just disabling it, right? Then in this database, which is completely empty, I create one table, DB store, with 3 columns, right? And then I create a store procedure. Store procedure will require one input parameter. What it does is quite simple. It's going to do a select of one column from the table where the parameter has entered it here. So then in my table, I just enter a lot of dummy data here. Right? If I do a select on my table, right, I see 79,010 rows. So what I'm gonna do right now is I will enable query store for my database, and I will execute my store procedure with the parameter 0 20 times. You see here, there are no indexes on the table that we just created. I just executed the procedure 20 times. I go to the user database here. I go to query store, and I go to top resource consuming queries. In here, I only have one query here, which is the one that I just ran, right? So here we see this nice chart of the amount of time that it used, etc. But if we want to see more insight, we go here and we see, hey, this one was executed 20 times, minimum duration, maximum duration, average, etc., etc. Good. We go back to this one, and I will create one non-cluster index, right, in one of the columns. So I'm going to execute it, and now I will execute the store procedure again, another 20 times, right? So I go back here, I check my query store, I will refresh, and now we see that, with the first plan, with no index, it used to take around 80 milliseconds, right? Now, it detects that there is another plan, right? Another index. So it changed the execution plan. You see in the first one, it was just a table scan. In the second one, it's just using the index, right? So it's way, way faster. So if we go here, you see, and the second plan was executed another 20 times and is way, way faster. Right? I will create another index, which is a covering index with 2 columns, and I will execute my procedure, let's say 30 times instead of. Going back here, refreshing query store. Now I see this one that was executed 30 times and is the faster one, right? And if we go back to the graph, we'll see that I have another plan, the 3 plan that is using an index 6, the optimum one for this one. All right. Which is interesting is that in here, if eventually for some reason I just want to force to use this plan, I just highlight the one that I want to use, right? And I hit force plan, right? And it's asking me, just for confirmation. And now, as you can see here, there is a tick, right? Which is saying that the plan is forced. So doesn't matter which is the optimum, it will be using the one I want, right? And again, this plan, the plan change, plan regression in this case was from a bad one to the best one because of the indexes. But it could be the other way around when there is a regression, right? It can start being good, and sometimes it's going to come up with another plan with the execution plan is way, way higher, right? With automatic query tuning, it will automatically switch back to the last known good plan, right? So really, really good. Memory grant feedback, right? What I have here is one of the demo database. I'm just changing the compatibility level to 160. I'm cleaning the query store, right? And doing an updated statistics just for the sake of the demo, right? And what I'll do here is that I have enabled the include plan. So I will just run this query, right? And it's going to take some time, right? Is, will take around 1 minute. Remember what is important here is the memory grant feedback. The first execution, it will compile the plan and it will come up with a memory assignment, right? And it will use it. And then the following one, it will be adjusted to, the right value to, be more efficient. And what you will notice here is that I won't change the code at all. I don't have to do anything, right? So it just finished. It took, it was around 50. Okay, no, I have to run it again. So let me start over. Otherwise, it's going to mess up the values. It's going to take around 50 seconds. It's going to run for the first time. It's returning the values, as you see. Right? I have the include execution plan enabled. So when it finishes, we're going to see the amount of memory that was granted and the memory that was used. And when you read an execution plan, every time that you see a warning sign, a yellow warning sign means that there is something that you have to review there because it's a warning, right? Again, doesn't matter if the memory is enough or not enough. SQL Server will always execute it, right? No matter what. If it needs more memory, it will always go to the 10 dB and it won't be any problem. So it just took 48 seconds, right? And returned 66,416 rows. If we go check the execution plan here, we see this, the warning sign here. So what is this? So if I hover over here, again, well, then I won't run it again because we have to wait another minute. So what it was saying is that the memory grant was too much, right? And it was using the 10 dB to spill to this. I will run this for the second time. Remember, it took 49 seconds, right? So now I'm running it again for the second time, and this time it took 2 seconds, right? I didn't change anything. It's the same query. So the first time took 40, 50 seconds, and second time took 2 seconds. Why? If I go to the execution plan, now we see that there is no warning here. So it's because the granted memory was adjusted. The first time it was not enough, right? That is why it used the 10 dB and took 50 seconds, right? But then on the subsequent execution, it just tweaked the value to take the right one and took just 2 seconds, right? So no code change, memory grant adjusted on the fly with absolutely no problem. The one for the scalar function, right? We will change the compatibility level, clean the procedure cache. Then I have this function, which is kind of simple, right? Or seems to be simple, is, customer category. So depending on the customer key, it will tell you if it is a regular, if it is gold, if it is platinum, right? So it's just a function. Then what we will see here is that this function, right, come here and, it has to be an inline function, right? Otherwise, we cannot use this feature. So the previous behavior was, I will change the compatibility level to 130, so we don't have this feature enabled. So I go here, I run it, we get the execution plan, and we see that it's taking some time, but when we will check the execution plan for this query, and here this query is as you can see, we are calling the scalar function with one of the values customer key, right? So this select top 100 is calling this function. When we go check the execution plan, we will see something that basically is kind of useless, right? We don't see the function at all, so it's not here. So again, SQL consider this with almost no cost, right? Compute scalar. It took 35 seconds. I will change the compatibility level. I will clean the procedure cache to start over, and I will run exactly the same code, right? This time, when we check the execution plan, right, we see that is faster, definitely faster. Again, no code change. When we go check the execution plan, now we see the whole plan here, right? Remember, the previous one was just the table scan or table scalar function call, and now we see, the plan for all the calls to the function. So before doing anything, it just compile the plan for the function and then embed it into the main query, right? No code change, twice as fast, so super, super good. Live query statistics, right? We have this button in Management Studio up here, right? Include live query statistics, right? So I will run this query, and what we see in live query statistic is while it is running, the zoom it definitely is not running properly. So I cannot zoom, but hopefully you can see it. Here, now I lost my mouse. Okay, hold on 1 second. second, I have to kill the summit. I lost my mouse pointer here, so sorry about that. 1 second, if I can kill it somehow.
I hate when that happens.
I lost the mouse pointer here, so I cannot even go kill it.
Maybe if you unshare and then reshare.
No, I don't have the mouse pointer. Yeah, I lost the pointer.
I was going to unshare him.
Oh, but then we might lose him for good.
Well, I wasn't gonna disconnect him from the meeting, just unshare.
Wow, this is actually the latest summit that I downloaded a few minutes ago. So I found kind of a bug, probably.
Steve
One
Clark
second.
is suggesting maybe the battery went dead in your mouse.
Summit. Okay, here we go. I found it. So now how can I kill it?
Yeah, I see it.
Here we go. All right, I just have to kill Summit with no mouse. So anyway, what I wanted to show you is that you have the estimated query progress in here, and you see the rows, moving on in each of the operators. I will show you another one. I'm killing this one, and I run this one here, right? So you see the live query statistics, the query is running, and you see the estimated query progress here moving up. You can also see it down here, right? Execution query, 40%, right? And with that, you have an idea of which point of the execution you are at.
It's really powerful when you see everything complete except for one little line going dot, dot, dot. You're like, oh, that's the problem.
Yeah, absolutely. So the last one I just wanted to show you is query store hints, right? So we have here a database, right, that we put the query store. We see that, it's in read write. So no hints. What I'm doing here is just checking my table, right? And I see that for each of these agency ID, I have this distribution of rows. And as you can see down here, for the agent ID number 101, I have 100,000 rows, but for the others, I have just few of them, right? So I'm running the store procedure, just calling with the parameter 101. It's returning, 100,000 rows, right? And when we see the execution plan, right, we have it here. Now, I run it again with another parameter, which is 4, right? And here, it just returns 3 rows. When we go here to query store, I would like to identify the query ID of the query that was just executed, right? The one that we executed right before is the query ID number 3. So what I'm doing here is, without code change, I will specify the query ID number 3, and I will say, hey, at this query, please add the query hint option recompile. I have the possibility of opening the store procedure and write option recompile, and then recompile store procedure, or just come here, right? Force it, right? We can see all the hints that we have enabled. It's just saying that for the query ID number 3 is using the option recompile. We can use any of the hints available, right? So then when we run the procedure again, it will always recompile the plan. And with that, we won't have parameter sniffing, for example. The downside is that every time that we execute this, SQL Server query processing has to recompile and come up with a new plan. The good part is that for every execution, we're going to have a new plan, so no problem with parameter sniffing. You saw that for 101, there was 100,000 rows, but for the others, just a handful. So now, it's always using the right plan. Mm-hmm. All right. Okay, summary, we have seen a lot of performance-related feature. Definitely have a look to SQL Server 2022, right? There are not only features related to performance, but also related to high availability, disaster recovery, security, right? And as every single SQL Server version, there are new T-SQL enhancements. Here we have, some resources. To me, the starting point is always aka.ms/SQL Server 2022. And from there, you can go grab all the other. You can go to the learning portal, the Microsoft Learn, and get all the documentation, all the details of all the features that we have seen today, videos, ebooks, and plenty of things for you to dive into and play around. All right. Here, one quote on the presentation for SQL Server 2022, right? Features like query store hints and the next generation of intelligent query processing are awesome. Possibility of improving and maintaining great performance over time without code change is getting better on every new SQL Server version. That was in one of the SQL on the past summit edition a few years ago. All right.
Does Bob know you took that picture and you got it on your slide?
Actually, he gave it to me.
You know how much he loves being put on slides.
Yeah. Well, as you saw in some of the slide, there is the MSC logo, the company I work for, right? Yeah. And well, we are partnering with Microsoft in SQL Server quite extensively, right? So we are we get private previews way before that anybody does. So we are actually the tester of all these features with our own workload. So that is great insight for both MSC and from Microsoft. So yeah, I definitely have this contact with Bob, and I was part of some marketing videos as well. All right, as I said, you have my contact information there, so don't doubt to reach me if you have any question. It was quite fast, but the idea was just to have a sneak peek of everything related to not only SQL Server 2022 performance features, but what I call all the modern version of SQL Server, including Azure SQL. That's it from me. Any questions around the table virtually?
Yeah, I had one. You were talking earlier about temp DB and how having multiple files for temp DB isn't all that important anymore. At one point in time, at least as recent as SQL Server 2019, when you installed SQL Server 2019, it would detect the number of CPUs you had and then create a temp DB for each CPU.
It will suggest, not create. It will suggest the number of files. You can change it in the setup. All right.
I was going to say in 2022, is it still doing that?
Yeah, absolutely. No, again,
Okay.
as I said, and this is directly from Bob Ward. If you see the demo of the contention on 10dB, doesn't matter the amount of files that you have, the contention is almost none, right? But, of course, the very first hand that was raised was saying, oh, so now I can create one 10dB file. Well, the idea is that no, you keep using the existing best practices on how to create the 10dB. But eventually, we all have seen this more than once. The casual DBA that they get asked to install a SQL server, so they use next, finish, right? And then they put the company most important application at the top of it, so the very first weeks is going to run well, and then the performance will be terrible, right? So with the combination of the setup plus all these new features, that doesn't matter if you have 1 or 8, right? The contention is not there anymore. I used to have environment with 130 files in order to avoid contention until reaching SQL Server 2022. Then now we went back to 8. It's just to avoid contention.
There's always gonna be that edge case out there, right? That somehow hits a bottleneck. And so you think about it, even if your temp DB files are really, really small, let's say you only have one PFS page, one GAM and one SGAM page, because it's a small file. Well, if you have 8 files, now you have 8 of them, right? And so
absolutely, that requires a lot of tuning and troubleshooting, right? So to troubleshoot GAM contention is not easy.
Right, but what I'm saying is, right, by having multiple files, you're automatically creating an environment that is set up for success, right? Because, and the same thing with with the auto grow or the grow of all the files. Because if you have data files in the same file group, which would be tempdb, that are different files, you can create a hotspot on a single file.
Yeah, well, now the problem
flow.
of auto grow that we used to have is definitely solved because those trace flag 11, 17, and 8 are now part. They are default. So the grow is always at the same phase. So you don't have 10dB files, one which is super huge and others that are small. So the distribution is the right one. But definitely is again, unfortunately I don't have the demo ready, but switching on and off this feature, which is on by default in 2022, right? When you hit the 10dB as crazy with and without this, you see a lot of contention versus almost no contention. And when you go check the 10dB, it's only 1 file on the demo. And with that, I'm not saying just go delete all your 10dB and leave only 1 file, right? Leave it as they are.
All right, thank you.
All right, very good. I hope you all enjoyed the presentation. And well, I guess now you're gonna have some good time over there. Mm-hmm.
Well,
A
thank you,
pleasure to
Thank
be
you.
here one more time. Thank you, Ross. Thank you, community, and well, see you around.
Great, thank you.
Thank you, Javier.
Hopefully see you in the past summit.
Yeah, look forward to it.
All right. Good night.
Good night.
Stop recording. So what do y'all think? Good? So what you expected? Did everybody know what they were coming here to see tonight?
It was different than I expected,
Good with it?
but,